webinar today. Our webinar today is titled Tackling the Communications Challenge in PCB Design-for-Manufacturing Handoff. This event is sponsored by Siemens Digital Industry Software, and we also have our speaker today from the Valor division within Siemens. Before we get to that though, and into the introductions, let me do a quick couple housekeeping issues. Number one, as our guest today, you are all muted. This is being recorded and will be rebroadcast on EMSNOW and made available to the industry. And we do invite your questions if you have any questions for our speaker today, and I would encourage you to use the question tab at the bottom of the screen there. That is always there. So that said, let me get into this. On a personal note, I have to say I've been very excited for this webinar since we announced it, because I think the solution we're going to discuss today is a great advancement for the electronics manufacturing industry. And I think after our webinar today, you will undoubtedly agree. So our guest today I will introduce is Oren Manor. Oren is the Director of Business Development for the Valor division of Siemens Digital Industry Software. So Oren, thank you for coming, taking time today to speak with us. And let me begin by asking you to introduce yourself and your role within Siemens for our audience.
Sure. So as you said, my name is Oren Manor. I've been with Valor, Mentor, now Siemens, of course, for about 8 years now. And I'm responsible really for our business development activities around electronics manufacturing. So really covering the extended portfolio that we bring to electronics manufacturing. We have done a lot of consolidation in the last couple of years and now have a digital manufacturing segment, which kind of brings all of the different applications for the manufacturing, whether this is process engineering, manufacturing planning, scheduling, the actual shop floor management, analytics, material flow. All of that is really situated today in one segment, which we call digital manufacturing. And I'm responsible for the business development as we take that portfolio to electronics manufacturing. Some of it, of course, is dear to my heart and part of the classic Valor, but a lot of it is stuff coming from the Technomatics portfolio, Camstar systems. So a lot of different acquisitions made over the years, which have formed this digital manufacturing division.
Mm-hmm. Thank you for that. And as I shared with you before we started, this is near and dear to me because in a prior role, I worked in the industry for a quick turn prototype shop, and we had a design piece of it, and we used the Valor tool in trying to help reduce spends and help our clients to get their products to market faster. So I think so I've been a fan of the tool, and I was glad to hear about what we now call PCB Flow. So Siemens introduced a new solution named PCB Flow at the beginning of April this year, I believe it was, and it's intended to bridge the gap between electronics design and manufacturing. So give us kind of a general description of what this solution is.
Sure. So PCB Flow is really a cloud environment. It's a cloud platform, and the idea is really to help make the whole design to manufacturing flow much more smooth, streamline it. And the first thing we're tackling with PCB Flow is really this issue of DFM. And DFM, I think, has been performed in the industry for many years, as you indicated. And definitely, many would say, yeah, it saves them iteration. It saves them finding issues very late in the game. But it's also, everybody will tell you, complicated, complex, and expensive. And what we're really trying to do now is democratize really DFM, bring it down to the masses if you want, and make it something that everybody's going to use without any doubt and nor any hesitation. So make it, I would say, easy, straightforward, and also affordable for really, I wouldn't say every new product introduction out there, but most new product introductions in the industry.
Good. And so to set the context for our discussion that we're going to have here, please, if you could ask you to speak to kind of the challenges of doing DFM and how this is still being conducted today in the industry. And as we do this, I'm actually going to open up a couple of slides that you shared that kind of speak to it very nicely.
Yeah. So I think that the key challenge, first of all, is how do I get my manufacturing process control and constraints modeled, right? I mean, in order to do DFM, a design for manufacturing, in the design ecosystem, I need to really understand what's my manufacturing ecosystem like, right? I have to get some type of understanding of how the manufacturing is going to be. What are the manufacturing capabilities? That's the positive way of saying it. The negative is what's the manufacturing constraints, right? What are the limitations? And try to check that. And obviously designers don't really know what the manufacturing constraints are because they're designers or they're layout guys. Yeah. So if I'm, let's say a top tier player, and I use one of the tier ones manufacturers and I have very deep pockets, I can go there, hire 3 or 4 people from the manufacturing guys who know the manufacturing process, understand manufacturing, understand SMT, PCB assembly, bring them over, and great, I have a team, I have it in-house. But if I don't have that deep pockets, I can try and go and maybe ask my manufacturer to share with me their manufacturing constraints. But as we say here, they don't really trust me with that data, right? They say, look, it's our IP. Right? And maybe I only make 200 boards a year. So who's going to give me manufacturing constraints, right? I'm probably, if I would be making millions of boards, I can probably get it. But if I'm a mid-size, customer of theirs, they probably will tell me, look, send us the data. Just send us the design data. We'll run it for you. I don't want to share my data, right? Because this is my IP, especially let's say I manufacture it in some low-cost country. I don't really know the manufacturer yet. COVID's been around now for a while. I might have never seen him face to face, never flown there. I'm using, a contractor. The work is excellent, but I'm still hesitant to take my design file, my CAD file, send it over there. I'm a small startup. This is, my whole life is in this design, and I'm not going to do that. And that's really an issue. So what we see happening is either people just give up and they don't do a real DFM analysis, and they don't do, I would say, any DFM analysis, or they decide to do something which is average. They create some type of manufacturing constraint file, but it's not really representative of the manufacturing process which their design is going to go when they go to their manufacturer A. Now, let's say that they do have, they have modeled it 3-4 years ago, and now in order to be more agile, they have bought 2 more suppliers. Well, have they changed the manufacturing constraints files? Probably not. I visited about 5 years ago in Silicon Valley a tier 1 manufacturer and designer of servers, and we asked them, so guys, how often do you update your manufacturing constraints file? They said, gosh, we haven't touched it in 10 years. The guy retired like 3 years ago. Nobody wants to touch it. Nobody even understands how to model these things. And this was really, a real tier 1 OEM. So you can imagine that updating and modeling this, and then really you catch some of the issues, but when you go to the actual manufacturer, he runs his DFM, you still find issues which delay you from going to manufacturing. So what we really want to do is allow the designer to get these manufacturing constraints, be able to leverage them. He doesn't have to see them, but be able to leverage them and know that they're accurate, up to date, and are really representative of the manufacturing process that is going to be subjected on his design. And I think that's really a key issue.
Yeah. And Oren, let me jump in because you mentioned that the constraints, the current constraints, but those constraints, of course, change even for a supplier over time, right?
Exactly. I mean, we can go and look at an SMT manufacturing like that, let's say a Flex 10 years ago and today, it's night and day, right? The machines are much better. The inspection machines are much better. The capabilities of the machines are lights away. So the manufacturing constraint file from 10 years ago is completely irrelevant today. Now, also, if I'm making a high density mobile phone, then I'm willing to really subject the device to very, very complex processes because I have no choice. But if I'm making some, networking board now, which is going to go on some base station, well, the size and is not an issue. I can take more space. So would they use the same constraint file? Probably not. If I'm doing a mil spec design, so also here, I really want to model it and say, okay, manufacturer can tell me, look, I can do high-end manufacturing. This is the cost. Low-end manufacturing, this is the cost. Depending on what you want to achieve, I'll give you the relevant process constraint file. So I think that also has changed. especially in the last couple of years, right? Flex rigid, a lot of changes in the industry where you really have to subject it to the right manufacturing constraint, which suits that design and what you're willing to pay, to get it into the market and get a good product market fit.
Mm-hmm. And let me ask too, because we've been talking here, and I'm looking at hopefully you see the slide, the design ecosystem, yes, manufacturing ecosystem on either side. But at the bottom, we have the components ecosystem, because of course, the board fabricator is that primary one there, and that's an important voice and partner to have involved as well, right?
Yes. Yeah. So from our perspective, components is two things. It's the actual discrete components that you're actually going to be placing. So the bill of material, all of the different ICs, capacitors, right, resistors, everything there. Because we know that in order to do a real DFA, design for assembly, you need very good modeling of the components. One of the issues we have is that designers, they do a cell, right? They have an envelope of the CAD package. They don't really care about the distance or between the pin and the body and the size of the pin and the type of the pin. But we go to assemble and we want to make sure that that pin is going to touch the pad at the right place and that the paste is going to be at the right location. We've got to model that. So we have to bring data from the components ecosystem in order to really get a very, very accurate digital twin of the manufacturing product and be able to do this type of simulation. And that's another thing which is really a challenge today. So if you have a top-notch process with librarians and every component that you add to the library, you get a 3D model, fine. But if you're a mid-sized company, you probably don't have that. And then your analysis again is very far from accurate. And we can find that maybe in your alternative vendor list, you're going to be using 3 different suppliers for this capacitor. Maybe 2 fit greatly. One is just, a little bit too big and will cause some manufacturing issues. So we would tell you, use those 2. This one, we would keep away.
Right.
Because it's marginal, right? So now, of course, also, so sending out today, traditional DFM is done offline, on-premise, no sharing of data. Really, the cloud opens the way to collaborate here, I think, in unprecedented ways, and really get that. Yes, if you go here, really, the idea is that PCB Flow, I look at it as an escrow, right? So we take the manufacturing constraints from the manufacturer and we store it on PCB Flow. Now, we're not sharing it with anybody. As a designer, I cannot see the manufacturing constraints, but I can see that a manufacturer here, a regional one, let's say from the Denver area, has published a constraint set and he's willing for me to go and send my device and subject it to my design. I will upload my design to PCB Flow. Nobody can see it. It's in a secure area that only I have access to inside inside PCB Flow. I can now run it against those manufacturing constraints and get a report. So I have a report. I know now that if it's all green, if I send my design to this manufacturer, they should be able to go right, and manufacture it. Shouldn't have any issues. I can also look at other manufacturers, maybe bigger ones, maybe ones in low-cost areas. I could compare. Now, can I try to reverse engineer some of the constraints? Maybe. But look, there's like hundreds of rules, thousands of variables. I would have to subject thousands of designs to try, and what is that going to accomplish me? That the minimal distance between 2 components is 3 millimeters? I mean, it's not really going to, right? It's not going to help. Right. Now, as a manufacturer, I can decide whether I am public and anybody can use my constraint sets, or if I'm private and I'm by invitation only, and we've got to connect before that, or I'm completely hidden and I don't allow anybody to even see me on the platform if they don't know I'm there. So we do have these precautions to really allow. Now, then me as a designer, I get a very accurate DFM report within, a minute or 2. I can download it, check it, see it, and I'm a happy camper. And the manufacturer he's guaranteed that if that design comes in, he's ready to go. And maybe he's won another customer, right? I mean,
you raised a lot of issues there that I'm going to want to delve into. But before we get into that, let me just also ask, because clearly you're creating this platform. How else has the industry changed that's kind of motivated the development of this solution? And has it really been accelerated by the pandemic and what's been going on globally?
Okay, so I think, yeah, a couple of changes. Well, first of all, we all know, right, complexity is up the roof. Complexity has gone really up, and the density. We see, a phone from 10 years ago to a phone today, so many more components and so many more layers, embedded components, flex rigid. All of these things have really made products much more complex. And if you could maybe, DFM a PCB, looking at a monitor and doing like manual DFM 10, 15 years ago, today it's obviously not practical and not really feasible. The other thing is, our customers used to do a new product introduction once a quarter. It was like a festival. And we have OEMs, which they tell me, we would drive down to the factory, we would come for a week. We had this room called, like NPI. We would sit there for a few days. Now they do 2 NPIs a week. Nobody can drive to the factory. So this needs to be a process which is streamlined, which is robust, and is really easy to do. And the third thing, when the batches were very big, and let's say you were going to do 10,000 PCBs, well, you could try and get your process into control, 50 boards, and tweak it, find some issues, go back. But now, where the whole batch is like 20 boards, 50 boards, you don't have the luxury of testing it. You have to know as a manufacturer that you're going to build it right the first time. Otherwise, your whole margin goes away. So it's not practical to really do this and spend weeks and weeks and trial on the production lines. Everybody knows that everybody understands today, they have to get the time to market down. There's all of these new product introductions, and they need a very streamlined and efficient process.
Okay. So this solution, the PCB Flow that you've created, is a software as a service platform too.
Yes.
And is intended to allow collaboration among the various partners that we were just showing. So I want to discuss kind of the various aspects of the solution in terms of both kind of the what and the how, right? The what it does and how it does it. Because I think these, of course, are very related issues. So this may not flow logically in my questioning. So please bear with me. But let's get into this.
Yeah.
What are the manufacturer, you've talked about some, but what are some of the manufacturability issues that are addressed by PCB Flow? And are there limitations to what can be done?
Okay. So at the moment, really what we're focused on is DFM. We have the design for fabrication, and very soon also will be available design for assembly. So both the burr board and the analysis of the burr board, and then also the assembly. And that's really what we allow today. We also allow, after you've done the DFM, we can also share the actual design files on the platform, so you don't have to go and send it via email or something like that. So once you've done that, and also any rejections or any comments, any technical queries can be done on the platform. So I do the DFM, I can then send over the file. Once I'm happy and I have contracted this supplier to build me 200 boards, I can send them my design file. He can send me back a list of issues that he still has found, he's looked at it one more time, he's detected a few things, he has a few clarifications, maybe, supply chain wise, some of the, components cannot be sourced. We know there is a global issue of components, right? He might say, look, I cannot source these 3 components. I'm suggesting you these alternatives, and then it goes into production. The good thing is this is tracked, this is online. Everybody knows exactly what is the file. It's not, when did you send me the email? Do I have the last email? Did I guess the latest? And all of these different things. So all of this is really taken care of. So I mean, this is really what we offer today. As we go forward, we will address additional issues of the manufacturing, such as the whole issue around quotation, the request for quote, the quotation. So that's another thing that we're going to start dealing with, the selection of the components. So from our perspective, at the end of the day, PCB Flow is supposed to be a one-stop shop for the designer. He's got a design, he wants to take it to manufacturing. We'll help him sort all of his issues to find all of the suppliers and get them engaged at limited time and limited revision space.
Okay, thanks. Let me ask some of the how questions now, how this is done. So how quickly, I think you said this.
Yes.
How quickly does this happen within?
Okay, so it's minutes. It could be a minute or 2 minutes. It's extremely fast because of 2 reasons. First of all, it's running on very high-end servers. Okay, so obviously the cloud doesn't have limitations like our computer. And it's also running on a Linux environment, which is faster than most of our Windows users. So both of these things really make PCB Flow much faster than traditional DFM analysis on a computer. And you did ask about limitations. So in general, no, there's no limitations. We didn't want to make this, crappy DFM for poor people. Okay, that's not the idea. The idea was to provide top-notch DFM, but simple. So what we've done, for example, is we have limited the number of issues you get in the report. Some reports can have hundreds of issues. Our basic report shows you kind of your top issues and the top things that we believe you've got to address. Yeah, there's some minor warnings. Guys, don't worry about it. There's too much noise. If you get a report with 300 issues, you're not going to even address them, right? So we really want to make it also. So we've tried to simplify it and hide some of the issues which were complicated, but we in no ways did we limit the number of layers or number of components or checks that we do, that we didn't do that. We are limited today from a file format to ODB++ and IPC 2581. And the reason is we really need intelligent CAD in order to run DFM. With Gerbers, it requires a lot of reverse engineering. And also we want to promote intelligent data formats. Guys, it's 2021, and you cannot send the Gerber file, which was a format defined in the 50s for plotter machines. I mean, the industry has to evolve, and we need to, all of the trust mechanisms are here. So nobody has any issues of jeopardizing their IP. Doing it with Gerber, I think, completely contradicts what we're trying to do.
Gotcha. And you reference it there, but let me ask, what format then is the output from PCB Flow? You mentioned the report.
So it's a report. It's a web-based report, which you can also download as a PDF. So at the end of the day, my output is a PDF report, either HTML or PDF. I can download it. I can always go back to the system and see all of my reports. And I can file it and say, okay, guys, hey, boss, I did the report, all clean. Great. If somebody comes in a year and says, Oren, we've got all of these manufacturability issues, I can take the report and say, guys, all clean, we did it. Might be an issue with the components, might be an issue with the manufacturer, not an issue in the design.
Okay, perfect. Now, and and you've referenced some of this as you've been speaking, but tell us the technical and hardware requirements for using the platform. It really can be any platform, right?
Any platform. You need a browser. You connect to to PCBFlow.com. You log in and you upload your design. The only thing that we said is the design at the moment is ODB++ and IPC 2581. All of the leading CAD solutions out there, and of course Mentor Expedition, but also Cadence Allegro, Altium, Zuken, right? All of them provide an ODB++ file format or IPC 2581. So this means that all of the different CAD players can come in, small CAD solutions, the tier 1, the tier 2s, everybody can output a file and upload it there. Really the only limitation at the moment is Gerber. And that again is because it's a very, very primitive file format. A lot of know-how in the design intent is lacking. And Gerber is used mostly because people are scared of their IP, right? So they just want to share the bare minimum. But with PCB Flow, we've put in those safeguards, which I think should make people, not afraid. Yeah. It is Siemens behind it. This is running on AWS, right? So Amazon, it's a very secure platform, which probably all of our credit card information, right, and our insurance, and who knows what's up there. So I think that we can trust it also, right, with our design data.
Yeah. And that's the process, as you're indicating. It's cloud-based, so it's, I believe, and I said this before, I think the first software as a service kind of solution from Siemens. Is that correct? Or
I think Siemens has a couple others, but yeah, definitely from the Siemens software division. The software division, it's one of the first. We do have a solution for additive manufacturing and some other, but it's really the first one coming around electronics manufacturing, and probably one of the first ones coming. And really also here, the idea is that, as you said, it's pay-per-use or SaaS. So we're not looking like traditional software. Hey, Mr. Customer, please invest $30,000, $40,000, $50,000 in software upfront, training, implementation, deployment. No need. You can enroll and you can either pay as you go or buy a subscription for a year. These are really the thing, and you can just go, and the basic model is $300 per DFM analysis. So you can go, put your credit card, and do a DFM analysis for $300. Could be a component, a PCB with 4 layers and 10 components, or a PCB with 16 layers and 3,000 components. Yeah. Same price and this. Now, of course, you make any change and you want to do another DFM analysis, you've got to pay them again. So it's per analysis, but really we wanted also to keep the pricing very basic and simple, and also a very low, you're right, no barriers of entry. We want everybody, not to even think about it. Make DFM something that you do because $300, of course I'm gonna do it, right? Yeah. And that's really the goal here.
Yeah. And then if I'm a design engineer and I'm waiting to see, and I'm curious what that feedback is, yes. I could do it off my computer. I can do it off my cell phone, I'm assuming, right? And I can just...
Yeah, if you have the design, you can do it on your phone. I mean, all you need to do is have a design. You can do it on your tablet, on anything. You can do it working from home, in the office, on the road. As long as you have an internet connection, you go up there and you do that. And we also allow you, of course, to connect with different manufacturers in order to run DFM with different suppliers. So if before you had modeled one supplier, now you can benchmark multiple suppliers.
Yeah, and I want to get to that because I think that's an intriguing piece of this is the, and by the way, let me step back first. So and you've mentioned it that you use Amazon Web Services is who you've contracted with for the cloud. So it's a well-established, safe environment that, and so a concern, as you've been talking about, is IP that people have as far as sharing. So this kind of helps ensure, I'm assuming, that unauthorized third people aren't hacking in, right? And
exactly. It's completely secure. It has a lot of security behind it, and basically means that you have a secured and allocated space on the cloud platform, and only you and people you allow in your organization can access those project files. You can decide that me as the team, I'm the only one who can access. I can give a few of my colleagues ability to access, so we can also share the different design there and look at the reports, but no other customer, no other supplier can have any type of access to your files. Nobody can see them. We don't see them. They're encrypted. So also nobody, from Siemens can go in and look at some design and say, hey, that's a cool design. We don't have access to any of it. And same thing with the suppliers. The suppliers load their manufacturing constraints. It's an encrypted file. It's stored on the system. We don't access it. We don't know about it. So, and we can decide when we do this connection, I can decide as a supplier to be a private connection. And only Eric, if we talk before that, and I see that you're a serious designer, I can tell you, what, Eric, I'm going to send you an invitation to PCB Flow. Join, we'll connect. You'll be able to run against my DFM analysis. But Joe or Bill, when they go on, they'll see that I'm locked. They won't have any ability to go because I don't want to have them look at it and then come to me with questions, or I'm afraid that they're going to reverse engineer it. So for the more traditional ones, we provide, again, a more conservative approach with more control.
Yeah. So in that respect, it has to be invited and accepted. So each side has to
by both sides. Exactly.
So now you've said it a few times. I'm curious about this aspect of it from the manufacturing side. Yes. What determines who the manufacturer connects with on the platform? I thought it might only be their approved manufacturer who they've worked with, but as you've been talking, it becomes clear they can actually expand beyond that, invite others.
Yeah. So I can decide, let's say, if I say to myself, I have nothing to risk, I'm a great supplier, I want to increase my business, and COVID is really my ability to get more business now, because a lot of OEMs and a lot of designers are struggling to manufacture overseas now, because we can't just get on a plane, go to China or Thailand and do the whole MPI review, right? So I want to find more flexible manufacturers, maybe around the US. So now is the time for me. I can decide to be completely public, and I don't have to share all of my constraints file. I could do a generic constraint file, which is my basic one. I share it with everybody. It's still encrypted, but anybody can use it. Once you come, and you tell me I want to do this type of mil-spec design, I share with you my mil-spec constraint file. So suppliers can have multiple constraints files on the system, And if you're, let's say, a tier one manufacturer, a tier one OEM with, hundreds and thousands of PCBs, and I'm willing to do the extra mile for you and do something which requires more process control, more quality checks, but, is feasible, then I can share with you a specific constraint file, which we've agreed on. It's only between you and me. With all the rest, I have a much more rigid constraint file. And but we have a business, you have guaranteed a volume, an expected volume from me, right? So it's worthwhile for me. And I also know that you know how to design, you understand PCB. With the rest, I'm a little bit more concerned. So it does give me this flexibility to deal with different types of customers in different ways.
Yeah. Now, how does this work then? Because I'm thinking, does this happen in real time, or is it kind of sequential?
No, it's an offline. So we have a tool called Analysis Definition Manager. It's a small application we give to the suppliers. They edit all of their manufacturing constraints. It takes them probably a day or two to edit and put all of the minimum values between, pad to pad, pad to the edge of the board, between trace to trace. They have all of these different definitions. They do that, they save it, they upload it to the cloud, and once it's on the PCB Flow, it's registered and it's logged in. And from now on, any designer which comes on PCB Flow will see that manufacturer on board and can connect depending on the connection policy that they've defined.
Okay, because I'm also thinking about designers who have uploaded, their design and are waiting. They tend to be an impatient group of people, right?
No, so the designers don't wait for anything. Me as a designer, I go on, I see the list of manufacturers, I select 1, 2, 3, 7, run the DFM analysis, get the report. Okay. And now I have it. Now, if tomorrow a new manufacturer will come on board, then I have to go back to PCB Flow and see that we have it. We also have a generic manufacturing constraint set that we've defined. So if you really want to do something and you don't want to select a specific manufacturer, we have our generic one. This is also kind of our free testing, which we allow completely for free to do. So if you're not sure about what this really means, how it's going to look like, we have our file, which is a generic one. It doesn't really model any specific, but gives you an initial analysis. You can do that one for free, see the report, understand what you're going to get, and then you can decide if it's worthwhile for you to pay $300 to run it against one or more real constraint sets published by the customer, by the suppliers. Now, of course, let's say that I'm based in Western Canada. I probably want to find a supplier that's also in Western Canada. Yeah, it's great to work with Texas and Mexico and other places, but I probably also want to have one regional one where if things become complicated, I get into the car and drive. So I can also search PCB Flow by city, by distance from my location, and kind of see what are the options. Now, as we get more and more suppliers on the system and the platform, then I really will be able to do one regional one, maybe one national one from a low-cost area, which can give me more competitive pricing, and one like a prototype, which is very fast but expensive. So I'll be able to really use multiple ones to model different types of scenarios.
Okay, excellent. Now, so tell me now, I mean, we've alluded to some of it, but I'd like to hear you speak directly to it. The benefits that this solution is intended to provide to let's break it up. Let's start with the design side too, the OEM or the design houses. What are the benefits that this is intended to provide them? Some of them are obvious, but some might be less so.
Okay, so first of all, I think get rid of all of this issue of managing DFM constraint sets. Messing around with having all people who really understand the manufacturing process, keeping up to date with this DFM constraint sets completely removed. And the other thing is really understand that when you subject the design to a DFM analysis, you're really modeling it against very accurate and up-to-date and specific DFM constraint sets to the manufacturing process that you're going to be subjected to. So not something generic, not something, which is great, but from a different side, but something that's very accurate. And this is really supposed to, at the end of the day, do the DFM, make the DFM very accurate. So when you send it to when you actually get the quote and provide it to the manufacturer, he should be able to take it into production within a few days, maybe 1 or 2 days, and not weeks now with iterations and questions. And I found this, please change this in the design, this in the design. No, something that's really ready to be manufactured and really make this whole new product introduction much faster, and also save costs and allow you to add suppliers in a very, often way. And let's say, just like we go on Airbnb and, look for a room or a house to rent someplace, which we've never rented before, just like we go on bookings.com and find the hotel. Well, make it easier for designers to manage suppliers, add suppliers, and, may the best supplier win, right?
Yeah. And there's now, but that also obviously results in better yields, as you're talking about.
Yes.
Ultimately better time to market for your product.
Better time to market, less revisions, less quality issues, and and also less RMA, less returning goods from the field, because many times the DFM things, they pass functional tests, but they break 6 months, 9 months later when they're stuck on a baseband station up in the Rockies, right? And getting the chopper there to fix it is extremely expensive. So these things, but I would say that has always been an advantage of DFM. So nobody, as you said, nobody argues that DFM is valuable. I think it was just always expensive and complex. So this should make DFM something. And also there's sometimes in the industry, people say, well, why do I need DFM? I have DRC. Well, DRC, the design rule checker, is extremely important, but it's really design focused, while DFM is a manufacturing focus. What you're doing could be completely legitimate from a design perspective and by the rules, but extremely complicated to manufacture, have horrible yield and a lot of issues. And probably if you're just going to make, 100 of these devices, you probably just don't want to make this type of gamble and want to avoid it. So I think this also makes it, easier to understand that DFM and DRC and DFM complement each other.
Yeah, that's a good point. And now, how about the other side, from the manufacturing side? So what's in it for them, right?
Look, I think manufacturers, at the end of the day, if we've discussed and you send me your design file, right? And then you send me a quote, and and you want me to go and start manufacturing, or you send me the design and say, Oren, when can you start building it? I want to make an order. And I start telling you, look, I can't build it. You've got issues here. I don't want to do that because I want to get my money. I want to get paid. I want to start manufacturing. If I tell you I can't manufacture, I am risking that you're going to go to another manufacturer and tell him, look, this guy, my local guy, you're saying I've got design issues. I have no time to fix them. I don't even know how to start fixing them. This is the 3 months, old layout design. He wants me to fix things. You're going to take me weeks to fix. So this way, I can really communicate my accurate manufacturing capabilities, my constraints. So when I get the design, I should be, able to go immediately and not have to disappoint my customer. Yeah. And I can be assured that I can win the business. It's a very secure process. I have nothing to worry about. I also don't have to share my constraints online, send them in PDF files, start hiding. Why don't I want to share them? I can get the advantages of making them available, but still not exposing my IP. Nobody gets to see them. My competitors don't know what I'm doing. So I'm also, safeguarding that. And I can win new business. Look, we're in the digital age. I can expose myself to many more startups out there, new designers, big OEMs, which might not be using me because they haven't heard of me. They don't think I'm any good. Now I can, start getting in touch with them. Yeah.
And that to me, that was an aha moment as I was studying up on this, was that, because I thought, well, of course, the designer, the OEM would invite their partners in and they would just collaborate normally. And then I saw the element where it's almost a business development tool for lesser or some other EMS who it gets them exposed, as you're talking about, to potential business. And there's obviously that, that whole qualification process has to happen, but it's a good way to begin the engagement, I would think.
Exactly. It's a good way to expose yourself. It's a good way to let people know that you're out there, that you make PCBs, flex rigid up to whatever 16 layers. These are the type of technologies, and invite people to come and bid. Right? COVID has made this all a very digitally connected world, and now you can be on a platform which really allows you to get new customers from around the world without any issue of language, time, differences, right? So a lot of advantages, I think, for the manufacturers.
Yeah.
And manufacturers, I mean both PCB fabricators and PCB assembly. So both of them, from our perspective, are manufacturers. Yes.
Yeah, and that's a good point. Yes. So, obviously you didn't just spin this out. You did some studies. This has taken a while to develop. You did some, I'm assuming, some beta testing of the platform and all that prior to its release. So tell us about that process, how it went, and kind of the feedback you received on the tool as you took it to the industry.
Yeah, so I think, the feedback we received is very positive. Our beta customers really like the fact that it's easy. It's kind of like we said, it's 1, 2, 3, right? You load the PCB design, you select the manufacturer, you run the DFM, you get the report. That's it. Really no additional issues. They had this notion that DFM is complex and DFM is complicated. They also really like the fact that the report is very visual. We have these tips that explain to you exactly what was the issue, what was that. I think that was a good thing. I do think that you do have to understand about PCB layout. We did have a few guys who came in, hardware engineers, but mechanical engineers. And they said, oh, we want to do we've never been doing DFM because we don't understand anything about electronics. They couldn't read the report. So I think it's also important to say, we can take away the manufacturability issues of it, but you have to understand about PCB design, because otherwise the report isn't very meaningful for you. So if we do have, OEMs which have completely outsourced all of the layout, right, the PCB design, they just really focus on the enclosure and the mechanics of it, well, they probably need whoever they have contracted to do the PCB to also do the DFM analysis, because you do have to have that type of knowledge. And we've also seen customers who, you said they would do DFM only for very complex designs. And they would always think like 6 times before they would do it, because it was like $1,000 for a DFM report or $2,000 for a DFM. Now it's, they don't even think about it. And we've had users who do 2, 3 DFMs a week now. And they said, back before, they did once a quarter. It was they had to go up to the boss and the boss's boss and get approval or try to sell it to the customer. And now they just, they do it all the time. It's easy, it's fast, it's quick. And as I said, it is collaborative, but it's offline. They don't have to wait for anybody, right? And they get it done very fast. And, it's also a good way for them to know that they're on top of it. I think from the manufacturers, we got a lot of reluctance at the beginning about exposing the constraint sets, about, making it a beauty contest. I think most of the feedback we get now is it's secure enough. They understand the advantages. They also see that they can protect themselves. They can also open up over time as they get more confidence. And it looks like they understand now that it's really a win-win for everyone.
Yeah. No, that's very good. Listen, I wanted to, before we end here, get some questions from the audience, and I just realized some had been posed. So I want to and I'll also encourage anybody out there, if they wish to ask some questions, please, you can pose those now. So let me just jump in on these in order. First one that was asked is, do you have an API that I can tie into my CAD program?
So no, at the moment it's not, that's maybe one of the differences between our on-premise DFM solution. So our on-premise DFM solution is connected to the CAD. It can run together with our CAD solution, whether Altium, Allegro, or Expedition, and it really runs on top of it. And I can kind of run the DFM from within the CAD cockpit. PCB Flow is a disconnected environment. I have to export an ODB++ file, send it to the cloud, run it, get the report. So on one hand, it's easy. On the other hand, it is an offline solution. So we don't offer this type of concurrent DFM running inside my CAD. I do have to stop for a second, get a file out, run it, get the report. So there are some advantages and disadvantages. There is a way for our on-premise customers, especially Valor NPI customers who are doing DFM on-premise, to use PCB Flow just for the sharing of the constraint sets. So for them, PCB Flow is not really a platform, but you can think of it like an antivirus, where before they actually run a DFM, they go up to the solution, make sure that they have the most updated constraint sets, and then run. So it helps a little bit on the collaboration, but it's not really the primary intention here, which is to do this type of very easy DFM analysis.
Okay, thank you. Now, you had mentioned it before, at least on one level, but the question is, how much per month or per year does it cost? You'd mentioned 300 for a DFM.
Yeah, so 300 for one DFM, that's the pay-as-you-go, or you can lower the cost a little bit by paying us $6,000 a year, and you get 2 DFMs a month. So
okay.
$6,000 a year, you get 2 DFMs a month, or 24 DFMs for the year, and you can consume them. And if you're out of it, you can buy another package of $6,000 for $6,000. So these are really at the moment the 2 packages.
Okay, very good. Now, and a good question actually was, do the manufacturers have to pay as well?
At the moment, they don't have to pay anything. It's free of charge for the manufacturers. We want them to come on board. We want them to publish. They're also, not getting, immediate benefit from this, right? They're making the designers. So at the moment, for the manufacturers, the platform is free. We're encouraging all manufacturers to join free of charge, publish their DFM constraints on the system, and get more and more users, and everybody will benefit.
How do they do that? Do they go to a designated site? Do they have to contact you?
So yeah, they can go to PCBFlow.com and just register and define themselves as a manufacturer, upload their logo. It's self-service, okay, just like you would go into any kind of portal and create your username and password and edit your account details. So like you would go on Facebook and create your profile. Same thing here. You go online, you create your profile. You can download a small application, which is this analysis definition manager I spoke about before. You edit the rules, you save it, upload it back into PCB Flow, and you're set to go. You can do 1 constraint or publish 10 different constraints. They're different depending on IPC class, depending on density, depending on regions. Maybe you have one for the US and one for Europe because it's different machines. So you can really, have multiple constraint sets to mirror the different manufacturing sites that you have.
And then through that same platform, it's the same ability to update it as, say,
update it, change it, keep it up to date, and you can go in there, edit the rules, change any one of them, and it's immediately updated. Any customer that goes in and DFMs against your constraint sets will get the most updated one from that point onwards.
Okay. Excellent. Good to know. Let me just check. I'm checking. I think that was the the gentleman who posed questions said thank you. That was the chat. So listen, before we end here, Oren, let me just ask, is there anything that we haven't discussed here today?
Maybe one point. I mean, I think people, I don't know how much people paid attention, but Siemens did announce the acquisition of Supplyframe about a month and a half ago. So a very significant acquisition, I think, for all of us at Siemens, which are around electronic CAD and electronic design to manufacturing. Supplyframe is a leader in this whole BOM management, BOM quotation, and we are going to start leveraging the Supplyframe data in PCB Flow. So one of the big things we're going to do next is being able to give our PCB Flow users some of the data that Supplyframe offers around, risk associated with components. Can you source the components? Are they available? If they're not available, what are the best alternatives? Is an end of life expected? And when we know today that there is a global shortage of components, we have customers which some components, they have a 60 months lead time, 60 months, which means basically 5 years lead time, which means you cannot source those components. You have to find an alternative one, which is close enough, or do a redesign and put a different type of component. And I think Supplyframe would really, help us there, because they will bring data about the availability, who has the components, where can I source them? Because otherwise, it's a great design, marvelous design, great components, but if you can't buy them, what's the point, right? And in this shortage, so I think that's kind of going to be one big advantage as we bring all of this data together on this platform. I think it's going to be another big benefit for suppliers as well as designers.
And again, I'm just thinking, as I hear you say that, the great benefit of that being a software as a service is that it doesn't require anything, right? It's just going to all those up will just happen, right? And they'll just be.
You'll be able to, once you upload your bill of material, you'll see the components and you'll see, your green, yellow, red. And if you click on it, it will say, 97% rank, you can get it. DigiKey has 10,000 of these, no problem, or it will be in yellow, end of life announced for, next year, caution, or red, and as we go ahead, we'll be able to take additional insights that we have from a lot of different applications, from really the Valor portfolio, and kind of bring them into PCB Flow, which is really going to be this, PCB Design-to-Manufacturing collaboration hub with more and more data. And as you say, nobody needs to install anything, nobody needs to update. You just go onto PCB Flow and see the new stuff, and you'll see, new, check it out now, and you can really take advantage of that, or decide not to. If you have your own and you're good to go, then that's great as well.
Yeah, no, that's very excellent. Thank you for that. So, Oren, we've come to the end of our time here, so I want to thank you. I think PCB Flow is an exciting addition to kind of the toolkit for the industry, and I think that's thank you for providing obviously very passionate and insightful commentary about this. I look forward actually to seeing how this gets adopted and how this continues to benefit the industry. It's an exciting development, and I think that hopefully, our viewers seemed interested, and as we speak more about this, I'm sure it should be well received. So thank you, sir, for your time. I appreciate it. And I would just tell anybody watching, if you're interested in what is being discussed here, reach out to Oren. He certainly is on LinkedIn, or is a good way to start. And I'm sure he can point you in the correct direction to get you connected with somebody in your area. So
I'll be happy to do that.
Okay, Oren, again, thank you very much. This is exciting, and I look forward to watching as it evolves.